Hello, I'm Professor Benavides, and I want to go ahead and go through a basic Python object-oriented programming example with you. Okay, so the idea behind this little application that I have here is that we're going to go ahead and create a class. Let's call it student. It's going to be really simple. It's just going to have name and age. So in this class, we're going to go ahead and set up the init method that will initialize the objects, followed by a setter method for age, setter method for name. We'll also put in a special method that will determine the type of student based upon their schooling level. In other words, whether they're anywhere from preschool to college. And we'll also develop a small descriptive method inside of there. So that'll be our class that we're going to go ahead and instantiate objects from. In our client class, that's where we're going to go ahead and instantiate the objects. Of course, we're going to have to import from the student class. And we're going to then go ahead and call the methods to where they make sense, such as, we'll instantiate the students. We'll then go ahead and describe the students. We'll go ahead and mutate the data for age so that we can go ahead and test the validation of data. So that basically for age, I'm not going to accept a negative number. And for name, I'm not going to accept the empty string. So one of the things that we're going to see here is that in the classes in Python, there really isn't there isn't public and there isn't private and protected concepts. It's all public. We can code in a way, simulate private data and public methods, but it really depends upon the coding of the programmer. And I will exhibit this. I will show you this, and that'll probably only make sense for those of you who have programmed in other C-based languages such as C++ or Java. So we're gonna go ahead in the client program, instantiate a couple of objects, describe the students, mutate the age attribute. We're going to then distinguish between using methods that will provide validation versus directly mutating an attribute without having to go through a method. And then we'll show the student data again to verify that the data was either updated or not. Okay, so let's go ahead and start Sublime. And I've got dual monitors, so it opened up in my other monitor. So let me go ahead and bring it in. And so the first thing I'm going to do is both of these files, and the reason we use different, they don't necessarily have to be in separate files. I mean, I could create my class called student and use it in the same file and have my client use it. But if you put them in separate files, you create modularity and you create more reuse capability. It's more in line with the concepts of object-oriented programming that we separate the class so that it could be used again. So I'm going to put both of these files in the same folder, otherwise they won't find each other. So I'm going to go ahead and go File, Save As, and on the desktop, I'm going to create a folder, and I'm just going to go ahead and call it Python _ OOP. You may want to call yours lab9 _ in your username, but this will work for me in my little demo. So I'm going to double click on this folder so that this file that I create will be in that folder. Now I'm going to create the class first because the service, because in order to instantiate objects in the client, I've got to have the class first. It's kind of like that idea. I mean, you shouldn't call a method unless the method exists, So very similar idea here. I'm going to go ahead and call this student. And I'm going to say, I'll put in _class.py. All right, so I'm going to go ahead and build a simple, rendition of a student here, okay? The student class. And then the other file that I create, I'm going to call it student underscore client, and that's where I'm going to instantiate my objects. So first of all, the first line on here, let's just go ahead and put a simple documentation on here. Student underscore class dot py. I'll simply just restate the name of the file. And I'm going to put in a doc string. Doc strings will be more important later on. As a beginner, it may not seem really important, but basically what people do is they print out the doc string so that you can see what the other programmer did, so you can understand the program in case you have a problem maintaining or updating the program. So this is a student class definition. So that's my doc string, right? So now I'm going to go ahead and name the class. And the idea here is that classes in object-oriented programming start off with a capital letter. And if it's one word, and if it's more than one word, the beginning of every word is capitalized. So in this class header, I'll say class, it's a keyword, right? Student. Put in the colon. And when I press enter, it will indent properly. This will be in the suite, the block. I'm going to have to create another doc string. Hopefully you're getting used to creating doc strings. Student class to model a student. Now, in elaborate classes, this may be quite a lot of documentation that you would be putting in. So the first thing that we usually do is we put in what other people would call, if you're coming from C++ or Java, and you've created a class, you create a constructor. A similar idea is done here, except it's called an init method. Okay, this is where we're going to create our attributes. This is where our data is created. Okay, so we'll create this special method, which is, methods start with DEF, stands for definition, 2 underscores, and then INIT, and then 2 underscores again. And then open parenthesis, and the first parameter must always be self. And then we're going to pass in what we're going to pass when we instantiate the objects. Now, every time I create an object, I could create a student with more attributes, but I'm just going to go ahead and use name and age. So I like to use the word new name to distinguish it from name, and new age. Because when we instantiate, these are the values that we're passing to create the object. So at the end of every method, we put in the colon and press enter. And that puts me in the right place within the suite. Indentation, remember, and white space is very important in Python. So the init method is a special method that initializes objects of your class. Okay. Let's see now. So the self keyword, very important. It receives a reference to the object that gets created. It's used to create instance variables that refer to other methods. It must be the first parameter. It is the current object that is being initialized. It kind of reminds me a little bit like this keyword that's used in Java. But here we must be very explicit and use the self keyword. So I'm going to put in another doc string. Getting tired of doc strings? So we'll then say initialize a student object. That's what this method's job is. This method will get called when we create the object inside of the client file. So now I'm going to go ahead and say self dot name. This is the attribute, and it gets new name. All right, and then self dot age gets new age. Okay. So these are going to be passed, and these attributes are going to be created. So I'm going to press enter, enter, and then to create another method, I've got to press the backspace key so I make sure that I've gotten out of this suite so it doesn't get mixed up. So I'm going to go ahead and create another method now, and this is going to be a setter method for age. If you're coming from other languages like from Java, basically after you create your constructor, you create a setter and a getter method for every private instance variables. But the concept of private and public or encapsulation is not necessarily, it's not solid. It's not a solid concept in Python. You know, so because we can actually access the attributes directly without having to go through a method. It's still advantageous to go through a method so that we can engage in data validation. Data validation is, like, say, for example, with the name, I'm only going to accept names that are not the empty string. Well, it's better than nothing. In other words, let's say they just press enter at the keyboard and they want to put that in. Well, I'm going to say, well, you know, it's empty string. Got to have a name. Same thing for age. Let's say that my validation, I'm going to say, you know what? I'm going to accept only positive integers for age, no negative or zero numbers. Okay, so let's start off with a new method, and we start off with the keyword def for definition, right? And we'll just say set age. Remember self, and then we'll pass in new age. Put in the colon and press enter. Put in your doc string. Every method should have a doc string. This one will just say validate. Validate a, you know, we'll say allow update of age if greater than 0. And then we'll say provide feedback either way. All right, so I'll start. And a lot of this validation is done, you know, with an if statement. You know, you can go ahead and use exception handling too, and throw an exception. But for right now, we're going to go ahead and just use if to test for something, right? So I'm going to say if new age is greater than 0, colon, press enter, and then I'm going to allow for the update. So I'll say self.age gets new age. Okay, and then I'm going to put in my print statements to provide feedback to the user that something did occur. So here I'll say, well, first of all, I'll go down one line, and then I'll say, just to make it look nice, asterisk, 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 right? And I'll say attempt change, and I'll use a little placeholder here and put the name in there. Put in a comma. And it's getting confused here because I should have used double quotes when I'm going to use single quotes inside. You know, so let me go ahead and change this one to the double quote so that I can use the single quote right in there. Otherwise, it gets confused, or I might have to use an escape code or something like that. And then we'll put in another placeholder and then put in new age. Okay, that should make sense as feedback. And then we'll have another print and we'll use a formatted string. And then I'll just go ahead and put in these little line greater than signs. It kind of like makes it look nicer. Age was updated. And then we'll put in the name of the person. Kind of makes it look, you know, customized. Put in the period. We want to make complete sentences, right? And now I want to have else. So that's sweet right there. I need to get out of it by pressing the backspace key and then typing in else colon, pressing enter, it puts me in the right place. So I'm going to be doing pretty much the same thing on there. I probably could copy and paste that, but I'm not going to. It's too tempting to do that. So I'll just, because it's very much the same, I'm going to go down one line, put in asterisk, 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 and I'll say attempt to change, put in the person's name, the object's name, age to UA. So I probably should have copied and pasted that, but you never know how it's going to go. Because I'm just saying, hey, there was an attempt to do it, but then now I'll go ahead and say, hey, age for the name of the person, cannot be less than or equal to 0, period. And then I'll say no update made. So it should make sense as far as feedback to the user is concerned. So in other words, if age is greater than 0, I say, hey, there's been an attempt to update the age and it was updated, okay? And I even specify the age on there, right? And the else on this is that if it's negative, I'll say, hey, somebody tried to change, you know, Bob's age to 13. So age for Bob was not updated. No updates were made, right? You gotta make sure you're looking for little typos as you go along. So that's our first now we're going to go ahead and do the set name now. And it's very similar idea. You know, you could probably copy and paste a lot of this, but you know, sometimes when you copy and paste, you either save time or you make a mess. So we'll say set name. And we'll start off with self, and we'll pass in new name. This is our method. Put in the colon and put in the silly little doc string. So we'll just say validate, allow, update to name if update is not empty string. Okay. Should I put a period? Right. All right, so then here we'll go ahead and perform our test. We'll say if new name is not equal to the empty string. In other words, there's nothing in there, right? If that's the case, then I'll print out something and say, use a F string. Got to go down one line. Let's put in the asterisk, asterisk, asterisk. We're going to be consistent here. Attempt to change name for, and then we'll put in the person's name. Okay, put in the period. And press enter, and then I'll go ahead and do the change. And I'll put in the title, because we're going to enter in the data in lowercase when we instantiate. Okay. And then we'll do another print, excuse me. And in this one, we'll go ahead and put in the 3 greater than signs and put, say, name for, put in the person's name, self.name, that's the placeholder, was not changed. Well, oh no, that's the if. Name was updated. Yeah, that's what we're saying. Name was, yeah. Name was updated to, and then specify what it was updated to. I was looking at the code on here. The sequence is important because I end up using it, and you want to have access to it at the right place. So let me tell you what I'm talking about here. So if it's not equal to the empty string, then we'll say attempt to change name for whoever. And if it's not equal to the empty string, then I go ahead and allow that. But I add the title case to it, and that becomes the new data. Name gets updated to the new name. So, like for example, let's say someone changes their name to get married. So, you know, you go to the lawyer and you change your name or whatever, right? So you have a reason to go ahead and update the name, or it was misspelled, or you know, for whatever reason, you need to change the name. So this is an assignment statement, you know. So new name in this particular case is then assigned a name. All right, that's the attribute. So in our else, we'll go ahead and print out another F string, or formatted string. And we'll go ahead and go down one line and put in the 3 little asterisks, you know, to be, you know, like super compulsive. Attempt to change, put in the placeholder, self.name to empty string. Right? You don't want to do that. And then we'll say print F string, in this particular case, name for the placeholder was not changed. Period. Okay, so that should make a lot of sense on here. And that's our second method. Press enter, enter again, and backspace, backspace, so that we can go ahead and start another method. This other method is the one that will determine the type of student, in other words, what level of schooling they have. So let's go ahead and start off with DEF, and we'll call it determinetype for the method name. And we'll pass it self. Colon, of course. Docstring. Hopefully I won't forget any of these. Let me know, right? And this particular one, we're going to return the probable level of schooling. I can spell it right. It's a comment. Given age. So this is just going to be an elif chain. So we'll say if self.age is greater than or equal to 0, and so we got some logic going on here. Self.age is less than or equal to 4. In that particular case, See, when you don't put in the colon, it does not indent properly. So you've got to put in the colon and press enter to get to the right place. So type gets, in this case, we'll call it preschool. Okay. Then we'll start our LF. We'll have to backspace and say LF and start a new condition, right? A new test. So we'll say, in this particular case, if age is equal to 5. In this particular case, we'll go ahead and say that type gets kindergarten. And then we'll have another LF. If greater than or equal to 6 and age is less than or equal to 10. In this particular case, type gets, and you can be doing copying and pasting of this and just changing things here and there if you feel that that can, make your typing go, faster. So type in this particular case is elementary. Let me show you what I'm talking about in terms of copying and pasting things. So like this one, if I copy it with a Control-C and go down a line and then do a Control-V, I did not indent properly. There you go. All I have to do now is just go in there and change this to an 11 and a 13. And instead of elementary school, we're talking about middle school. Right? We could do that one more time. In this particular case, we're going from 14. What I mean by copying and pasting, you're either going to do something really good or really bad. If you have like your relational operators pointing in the wrong direction, you create like a royal mess. You may not be able to see where you've gone wrong. In this case, we're going to put the person in high school. And elif greater than or equal to 18. In this particular case, we'll just say type gets, and we'll just say college. Okay. And then we'll have a general catch-all for good luck. And then press enter, enter, backspace, and then have your return statement. Return what? Return type. That ought to do it for this particular method. Enter, enter, and then backspace so that we can go ahead and start a new method. The next method is our last one. This is where we describe the student. So we'll start off with DEF, describe student. That's self. Put in the colon, and hopefully I haven't forgotten any doc strings. Display a summary of student information. All right, so what I'm going to do here is have some print statements. And I'm just going to go ahead and say, \n, name, colon, space. I'm going to go ahead and do a tab escape code. And then I'm going to go ahead and put in a little placeholder. In the placeholder, I'll put in the name. Okay. And we'll do this again. We'll just put in age, right? We don't need to press enter here because the print has a return at the end of it. So we'll just say age colon, and then we'll put in the \T for a tab. I probably didn't even need that space in front of it, but I did it out of compulsion. Right? Put in the little placeholder. In this case, it's self.age. So that self thing, it kind of like lets you select from the drop-down list. So let's go ahead and put in our last, string here. So type, and we'll say tab, and we'll put in self, period, and then we'll say determine type of student. Determine type. Got to put in the parenthesis on here. Pressing enter, and I think I'm finished. Let me just look it over real fast. I've got my class definition. I've got the init method, which initializes my objects when they're created. I'll do that in the other file. I've got age, the age method, the set age method, the set name method. Everything that it says should make sense. So I'm trying to look that over. So sometimes you may say something that you didn't intend to say, and then sometimes people get their relational operators all mixed up, but that should do it. So let me do a control B. And when I do a control B, it's just, just to make sure that it's saved and it ran all right, it finished all right. So now I'm ready to go ahead and start working on my client. So we call this client service because, it's old-fashioned terminology and that the client uses the class and this student provides a service. So, it's kind of like generic OOP way of thinking. All right, so I'm going to go ahead and put in another file. I'm going to go File, and then New, and then File, and then Save As. And I'm on in the right place, and I'm going to go ahead and call this student underscore client .py. All right, so now I'm ready to go ahead and start my client. First line here, I'll just go ahead and put in the name of the file. And then I should put in, well, that's enough. Okay. So the next thing we're going to do is go ahead and put in the import statement. I was going to put a comment on there, but you know what it is. If I say something like this from student class import student, yes, that is an import statement, right? So I don't really need to hopefully comment that. Let me do it here. Let's try that again. All right. So that's my import statement. Now I'm going to instantiate two student objects. And I should give them a better name, but S1 ought to do it. So S1 we'll call student, and we'll pass Benavides. Notice I'm entering this in a lowercase, and then we'll put in age, right? Then we'll put in another student, and I am a perpetual student who doesn't go to school because I'm always teaching myself. Things are always changing, no time to go to school. And that's fine. Thank God I can read, right? So Melissa Gonzalez, my niece, 17. She's not 17, but I'm just putting that in there. Then we're going to print the program header. And now we're ready to go ahead and call some methods. First thing I'm going to do is I'm going to go ahead and call a method to see what's inside of student 1. So we'll call describe student, student1 dot describe student, and then I'm going to call the same thing for student 2. Look at, you notice that in Sublime, you don't get the IntelliSense until you typed that method in once before. Other editors are a little bit better in terms of how much help they give you, like Visual Studio Code. What I should probably do right now is run it just to see how it's going along. So I've always preached build incrementally, just to see if this was working. So what do I get so far? Let's see if I'm surprised. It's putting in Bob in lowercase age. Did I forget to do something in here? Yeah, I think I forgot the title method inside of the constructor. Yeah. So let me go back over here to the, and this is probably why you should probably code and build and code and build. Right in here for name, put in the title. Do a control B on that file, right? Come back to the client and do a control B. And there it is. So now Bob Benavides is in proper case. And due to his age level, he's most likely to be in college. And due to her age level, she's most likely to be in high school. Now we're only going to do 2 objects, but you know, if you're going to want to test this, that LF chain, since we're not using a prompt, you may want to go ahead, if you're doing this, you know, if you had time to burn, right? You may want to test out each category from preschool to kindergarten to elementary, or every single level, just to make sure that you've gotten them all. You know, that's brute force testing. Later on, we'll talk about some better ways to go ahead and test your code on here, right? So let's come back here to our client and continue to build. Now I'm going to mutate the data to of student 1. So I'll say student 1 dot, and what I'm going to do now is I'm going to call the set age method, and I'm going to pass it the negative number, the no, and see if it catches, right? And then I'm going to go ahead and have one that catches and one that accepts. So for student 2, for Melissa, I'm going to put her down to 13. That's going to change not only her age, but when we run the student information again, you're going to see that it's going to go ahead and change her probable schooling level. Okay. Now I'm going to come back to the middle here, but what I'm going to probably what I want to do right now is I want to get these 2, copy them and put them down here, because what I want to do is I want to show you that, you know, in fact, things were updated or that things did change, right? So let me go ahead and run this. And so I've got here's the first 2 calls to student information, and then here that catch for validation says, hey, attempt to change Bob's age to 10. Age for Bob 10 can age for Bob Benavides cannot be less than or equal to 0. So no update was done. Well, how do I know no update was done? I went ahead and called the student information again so that you can verify that he is still 65. However, for Melissa's age did not violate the validation rule. So she went from 17 to 13, and she is now in middle school. Okay, so these are working. This is working so far. What I want to close with, or I want to go ahead and is talk about how you can go ahead and directly modify the attributes without having to go through a method. You see, line 13 and 14, I'm going through a method, you know, to change age. And that's the way, you know, encapsulation has taught us in the programming languages. Private data, public methods, you got to use a method to update the data. Let's go ahead and see how I can change the data without having to go through this. In other words, this is public. This is as if I was in Java and declared the attribute as public rather than private, which is a violation of encapsulation. So S2 dot, and I know those topics may not be clear to everybody just right now, but guess what? They're really important ideas, and sooner or later you're going to need to know them. But for right now, understand that in line 13 and 14, I'm using a method to update the data, and it allowed for validation because I had an if statement that didn't let me change the age to a negative number. So let me give you an example how I can access the attribute directly without having to go through a method. So for student 2, let's say Melissa gets married, hopefully one day, right? And so now she becomes Melissa Cantu. All right, so let's see what that does. So as you can see here, it did allow for the update without having to go through a method. I accessed the attribute directly, object.attribute. There was no formatting done on this. I want to go ahead and contrast this with the other ways. So let's comment this one out, and let's go ahead and say s2.setName. And I'm going to pass it the empty string. We haven't tested this yet. It's the method this is the method that we haven't used. Okay, so let me go ahead and run this, and let's see what it says. Right here, attempt to change Melissa Gonzalez to empty string. Name for Melissa Gonzalez was not changed. How do I verify it was not changed? I ran it again, and she is still Melissa Gonzalez. So that method that we didn't use before called setName, let's take a quick look at it. It tested to make sure that there was something to be updated. If it was the empty string, which is nothing, right? It didn't allow for the update. Pretty good, right? So let me comment that one out. Let's take it a concept at a time. And this last one, I'll go ahead and say S2 dot, and we'll do set name again. And we'll pass, let's pass Melissa Cantu. And see what happens. Control B. And let's look at the whole thing from the very beginning. So we've got our 2 objects on here. Melissa's still in high school. We changed her down to 13, so, and now Melissa's name is formatted. Why? Because we went through a method that tested for that, okay, and allowed us to, when we ended up, if it's not equal to the empty string, I end up using the title method to the new name, Melissa Cantu, and I assign it to the name attribute. Okay, so that my output then shows capitalized letters on there. I like to go ahead and end this with my compulsion. I know I like to have a print statement. If you haven't gotten the idea by now, I like that. I'm going to go ahead and uncomment all of these except the first one, because it's the first one that I want to contrast with the other ways. Line 16 is accessing the data directly. Whereas example, like say for example, 17 or 18 or 13 and 14, lines 13 and 14, they're accessing the data by means of a method. And so you can do it either way. Let me go ahead and run it one last time so that we can verify that we're putting in Melissa Cantu and I am accessing the data directly on here. I'm making an assignment directly to the attribute right here of name without having to use a method to be my interface to make the change. So this is the basics. This is basic object-oriented programming. You always have to go ahead and create your class first. Once you create your class, you know, you go ahead and create your client that uses the class. You create your objects, and then you're most of the time calling methods in that class. And I think they teach us that one of the qualities of a well-designed object-oriented programming program is that your client has less code than the service. So it's a quality of good design, because all of the work, most of the work, is in the student class that provides the service. Inside the client, I have less code. So what does this do for us? It brings home the idea that in object-oriented programming, we want to be able to reuse that the class, and so that we don't. So most of the work, most of the things that need to get done, need to be defined within the class. All right. So hopefully, you know, this is your first object-oriented programming. I know I threw in some concepts from other languages such as C++ and Java, but basically it's the same idea. I'm using two files, one for, you know, my class that I'm going to instantiate objects from, and right here I'm going to leave you with lines 5 and 6 where you instantiate the objects. I've got S1 for student 1 and S2 for student 2. And I use the dot operator to access the methods in that class. So I could create many objects based upon this class, where I could describe every particular student. I could set the age of every particular student. I could set the name of every particular student. So the power in object-oriented programming is when you have a lot of code reused, not necessarily in small little toy programs like this. Okay, well, that's all I have to say about basic object-oriented concepts in Python. Thank you.